Hey everybody, it's Mr. Carr again. Today we're going to be talking about 4-4 here. It's about complex numbers. Okay. Complex numbers have to do with really this first idea right here. What happens when we take the square root of negative numbers? Traditionally, you've always said, well, you can't do that. It's not possible. So you just say no solution in the past. Now we're going to change that up a little bit. We're going to have imaginary numbers as what we're introducing here. So when a negative number is under a square root symbol, it's creating what's called an imaginary number. Okay. To help show us that imaginary number, we're going to kind of simplify it a little bit. And what that means is we're going to remove the negative from under the radical. And instead of having it as a negative number, we're going to call it the letter I. So every purposes we look at is I will equal to a square root of a -1. So when we simplify this radical, for example, normally if I took the square root of 28, I would say, let's break it down. You got 4 times 7, and then you can square root 4 as a 2, and then square root of 7 stays the square root of 7. But with a -28, doing the same thing, but first thing I want to do is I kind of want to take a -1 to the front. So I take the square root of -28. I'll do that, split it up as a -1 times 28. And then I split up the 28. That's 4 times 7. Okay, so this is all right here. This is the square root of -1. I got the square root of 4 and I got the square root of 7. Square root of 4 still becomes a 2. This right here is the key part because the square root of -1 is going to be treated as I. So I'll just make it 2i. Square root of 7 stays inside. So this is my simplified version. And that's the key right here. And that's the biggest part of today's understanding. I is representing the square root of -1. So I'm doing my breakdown like this. So we have 2i times the square root of 7. We can do other things with that. We can do our products of our imaginary numbers. And it's going to be kind of weird because we're going to multiply two imaginary numbers together and get a real number. So let's start off with this. We're going to actually do this as, I'm going to leave it as a square root of 12, but I'm going to put an I in the front. And then this will be I times the square root of 2. With our multiplication now, like this, because it's I times square root of 12, I times 2, or I times square root of 2, we can do this in any order we want. So I'm going to put the i's together and make it I squared. And then this will be the square root of 12 times the square root of 2. Well, real quick, if I is equal to the square root of -1, I squared is equal to the square root of -1 times the square root of -1. So if we remember from before, if you take the square root of a number times the square root of itself, then the answer is just that number. So I squared is actually the same as -1. If you were to do I to the third power, that would be the square root of -1 times square root of -1 times square root of -1. You would end up getting a negative square root of -1, which is the same as -I. So we can kind of simplify I to the third. I to the fourth is going to be like taking I squared and I squared. It'd be like this. It'd be I squared times I squared. Well, we saw that that's -1 times a -1. So that turns into a positive. So that's kind of repeats this pattern for all of these. I is the square root of -1, and it's just I. I squared turns into a -1. I to the third goes to -I, and then I to the fourth goes to a +1. Okay, and that pattern. So that I to the fifth would go back to I. I to the sixth would be -1, I to the seventh, and so on and so on. So that means I have I squared, which turns into a -1. Then I have 12 times 2 that I can put together in my radical. So that's -1 times the square root of 24. And now we can break down the square root of 24. So 24 is the same as, whoops. Yeah, let's skip the -1 for now. 24, if I break that down, that is going to be 4 times 6. 4 is a perfect square. 6 is not, and there's no other perfect squares inside of that. So this will turn into -1 times 2 times the square root of 6, which is -2 square root of 6. Okay? And so again, we first turn this into expressions with I. We put the i's together to make I squared, which turns into a -1. Then these go together as 12 times 2 is 24. And then 24 just breaks down like our normal rules. So we look for our perfect squares like this, break it down to a 2, but we still had a -1 in front, so we multiply those together as that. And then square root of 6 goes here inside because it did not pair up. So that was square root of 6 there. All right. Some other operations. We can do multiplication right away like this. So again, that's -3 times 2. It's all multiplication, so I can do any order I want. So -3 times 2 is a -6. I times I is I squared. As we already established, I squared is the same as -1. So this turns into -6 times -1. which is a positive 6. Complex numbers is going to be made up of any number that's written in this form, a plus bi. A and b are real numbers, but then I is that imaginary unit. So we have the real part, which is the a, and then the imaginary part, which is the bi. Okay, so the real part like this is the 1, the imaginary part is the negative 3i. So we can do things like that with our other parts right here. So this complex number. Find values of x and y that make the equation 2x plus yi equal to this. This, we're just going to match up their corresponding parts. So for example, 2x and negative 14 are the real parts. So that means that 2x has to equal to a negative 14. I subtract that or divide that out, and I get a negative 7. Okay, so x is a negative 7 here. yi and negative 3i are my imaginary parts. So that I know that yi equals a negative 3i. Well, if that's the case, I can kind of just ignore the I cancel out or divide it out. Y equals a negative 3. That's the only way for that to work. So those are my 2x and y values here. Adding and subtracting complex numbers, we're just simply going to treat I like a variable. It's just one variable that it has to stay the same all the time. It always represents the square root of negative 1. But we're just going to do this like combining like terms. So I'm going to do my first rule, which is let's distribute the negative sign. So 4 minus 6i minus 3 plus 7i. Well, then I combine my like terms like negative 6 and positive 7, 4 and a negative 3. So I have 4 minus 3 gives me 1. Negative 6 plus 7 is going to give me 1, but then that's a 1i. So just like if it was x variable, I keep that as part of my answer. So 1 plus 1i is the simplified version here. We can also treat it just like if I were distributing, and we're doing this as two binomials. So we're going to distribute here. So we have 3 times negative 2 and 3 times 5i. So that's 3 times negative 2 is a negative 6. 3 times 5i is a 15i. 2i times a negative 2 is a negative 4i. But then here's where it's a little bit different because 2i times 5i is a positive 10i squared. We do have our like terms right here in the middle. So negative 6 plus that will be 11i. So 15 minus 4. But then because the I squared, remember that's negative 1. So this turns into a negative 10 because it'll be 10 times a negative 1. So I actually do have other like terms right here. So this turns into negative 16 plus 11i. And that's my simplified version. So when we're multiplying out these complex numbers, we'll kind of always end up with this complex number right here, which is just a real and imaginary part like that. If we're dividing complex numbers to help simplify this, so it says simplify for my directions. Okay. The thing about this is when we say simplify, square roots and imaginary numbers should not be in the denominator. So we do not like the I here. In order to get rid of that, we're going to multiply the numerator and the denominator by the conjugate of the denominator. The conjugate is basically the opposite sign of everything that's in there. So for example, if it's a plus bi is my imaginary part, the conjugate is a minus bi. So that's what I'm going to do here. So we're going to multiply this denominator by 3 minus 2i. Okay, and you'll see what happens when we do that and why it gets rid of my imaginary part. But since we're dealing with a fraction, we also have to do it to the numerator, like that. Okay, so we'll start with the numerator. We've got 5i times 3 is 15i. And then 5i times a negative 2i is a negative 10i squared. Okay, underneath, I'm going to have 3 times 3 is a 9. 3 times negative 2i is a negative 6i. Positive 2, and do positive 2 times 3 is a positive 6i. And then positive 2 times a negative 2 is a negative 4i squared. Take a look in the middle. My like terms are going to go away. They're gone. Negative 6 plus 6i is no longer there. I squared is negative 1. So this is going to turn into, for my denominator, 9. Instead of minus 4, it's going to be minus 4 times a negative 1. In my numerator, I have negative 10i squared. Remember, I can simplify this. That's going to turn into negative 10 times negative 1. So that can turn that into a positive 10 plus 15i. Okay, From there, we can go ahead and simplify down here because we got -4 times a -1 is a +4, then 9 plus that. So this will turn into, I'm just going to write it down here for a little more space, 10 plus 15i all over 13. Okay. And that's my simplified version. Notice that there is no i's down here. Okay. I can also split it up as two fractions if I wanted to, because I could write it as 10 over 13 plus 15 over 13i. That's an option. But really the key is we do not want there to be a imaginary number in my denominator, which is what I have here. I got 13. Okay. Again, the conjugate eliminated the I in the middle. And because of the I squared, it turns into a it turns into a -1, which is now a real number. One more time for dividing my complex numbers. Technically, my conjugate pair is a little bit weird here. All I need to multiply by is, well, all I really need to multiply by is I. I don't have to worry about conjugate. So again, conjugate pair was if I have it in this setup, a plus bi, a minus bi. Here, if the goal is to get rid of the imaginary number underneath, we're just going to multiply by I. I do the same thing to the top. But just remember, you're distributing with the numerator here. So if I have that, I got 5 times I is 5i, and then I times I is I squared. In my denominator, I'm going to have 2 times I squared. We're going to simplify all the I squareds. That'll be 5i plus a -1. Then this will turn into 2 times a -1. Okay. I usually like to rearrange it so that the real number's in front. So I'll have -1 plus 5i all over -2. Okay. You could redo this a little bit because you're dividing by a -2. That means this could turn into a +1 minus 5i all over 2. Or I can separate it as two fractions, 1/2 minus 5 over 2i. Okay, so that is our last example. Yep, that's our last example. So again, complex numbers, the key part is you're dealing with I, which is representing the square root of -1. So all of your operations have to deal with that. Treat it like it's any other variable, except when you get to an I squared. Then you can always turn I squared into a -1. The other big part about today, conjugate pairs. When we simplify our fractions, we always want to make sure we get rid of the imaginary components. So we can use conjugate pairs, or we just simply multiply by an I to turn into an I squared. Okay, and that's it for today. Take care, everybody.